Okay, so next step, we're going to talk about static charge. Okay, now remember that we come across charge before because when we talk about current, current is the amount of charge in coulombs divided by time taken. So the amount of charge in coulombs passing a point in the circuit per second. That is current. Right? Now, this charge is not moving, so we talk about static charge. Okay, so this is like the charge that moves in electrical current, but this doesn't move. And again, it's usually we're talking about electrons that carry this charge because it's electrons that can move around with the charge. Okay, so we're usually talking about electrons accumulating or electrons moving from one place to another, and this causing a build-up of electrical charge. So static electricity is due to electric charge that builds up. Now, if it's building up, we're not talking about conductors because the charge could flow through the metal, for example, metal conductor. So we're talking about insulators, insulating materials, for example, a plastic comb. Now, because these electrons cannot flow through the plastic, because plastic is an insulator, the electrons build up on the surface of the insulator, the plastic comb, and so we accumulate this charge and it hasn't got anywhere to go, can't flow anywhere. So the charge has built up on the surface of the comb, cannot easily flow away from the insulator, so it's not moving. That's why we call it static electricity. Now, very quickly, we know that all materials are made up of atoms, the individual building blocks which make up everything. These atoms have electrical charges. We've got electrons that orbit around the outside of the atom that carry negative charge, and in the centre, in the nucleus, we have protons which have positive charge. And usually in an atom these charges balance out, the negatives balance the positives, and overall we have zero charge. Okay. However, electrons don't always stay attached to the atoms, and we can remove or we can transfer electrons sometimes by rubbing or friction. Static charge can build up when two insulating materials are rubbed together. Okay, one of the materials will give away some electrons and the other material will accumulate some of these electrons. So friction causes electrons to be transferred from one insulator to another. So one of these objects will accumulate electrons and get an overall negative charge. The other one will lose some of electrons and get an overall positive charge. So friction or rubbing can be used to create or to build up a static charge. So here, for example, we're rubbing this insulating rod with a cloth. Electrons are moving from the cloth to the insulator. So the cloth gets positively charged and the insulator gets negatively charged. Here, we're moving from the insulator to the cloth, so the cloth gets negative and the insulator gets positive. And this depends very much on the materials that we're rubbing together. Okay, so either the insulator can get positively charged because it loses electrons, or the insulator can get negatively charged because it gains electrons, depending on what each of these materials is made up of. Okay, so here we've got overall negative charge on the insulator, and here we've got overall positive charge on the insulator. So let's have a look at acetate. Okay, acetate rod and a cloth. Electrons tend to move, if we rub it, from the rod to the cloth. So acetate tends to build up a positive charge because it's lost electrons, transferred them to the cloth. If we look at polythene rod, rub it to the cloth, electrons tend to move from the cloth to the rod. So the polythene rod gets a negative charge and the cloth is left with a positive charge. Okay, so the difference there is the type of material. Acetate, polythene. We don't have to remember which are which. Okay. Now, one way that we can detect charge is by using a Goldleaf Electroscope, which I will record a video of this and the Van de Graaff to share with you. Now, the working of the Goldleaf Electroscope, we have a earthed metal case, a metal case that's connected to the earth to discharge any charge that's built up on a metal case. Inside we've got I've got a metal disc and a metal rod connected together, and here we have an insulating collar so that this metal does not touch the case. We have a very light piece of gold foil here attached to the metal rod. So if the metal plate becomes charged, let's say it gains electrons, for example, gains a negative charge, this will flow down the rod and flow into the gold leaf. And at the bottom here, we'll get the negative charge in the rod, and we'll get negative charge on the gold leaf because it conducts as well. So the two will repel each other, and the gold leaf will start to stand up. Okay, and we can look at the amount of charge building up, measure it on the scale here. The more it stands up, the more charge is building up. Now, a Van de Graaff is a machine used to build up static charge using a motor. So we have a rubber belt which rubs against a piece of mesh that's connected to this dome, and electrons will be rubbed off the belt, for example, at the top. Electrons will accumulate here, and this is made, the rubber and this frame is made out of plastic, so it doesn't conduct. So if the top gains negative charge, then the bottom will gain a positive charge. Okay, electrons will be rubbed off the rubber at one end and picked up at the other end. This can accumulate quite large amounts of charge and produce very high voltages that we can then use for doing all sorts of experiments. So let's see it working. Van de Graaff has got his rubber belt. Okay, so here's what's happening is we're getting a positive charge accumulating on the top because here electrons are being picked up and carried down to the bottom part. So electrons are being passed from the belt to the bottom part here, leaving the belt positively charged, and so then electrons will flow from the dome to the belt here and get carried down again. If we bring an object that's connected to the earth close to this positively charged dome, we will get a very high, if we accumulate a high enough potential difference, we'll get a spark jumping from the air as electrons are brought up from the ground, from the earth, into this sphere, and then jump across into the positively charged metal sphere. If you were a person and were insulated by standing in a bucket or on a tray, and we touch the dome, then we will build up a charge. And the most famous bit of this experiment is if we build up a charge and all of your hairs and your body, everything gains a positive charge because you're insulated and you're not touching the earth, then your hairs will, each of your hairs will repel the neighbouring hair, and so your hair ends up standing up on end because your hairs don't want to touch each other. Okay, so static charge. We've got a Google Doc as well with this, so if you want to make some notes in your Google Doc,